Hello, hello, hello. There are two parts to this intro of this video. First part is going to be pretty short. Here is my cat. His name is Momo. Momo broke my glass humidifier hood. So now I need to 3D print a replacement hood for it, right? Instead of glass, of course, plastic. Second part is, well, why you clicked on this video in the first place. A year ago, I've shown you a beta version of this free browser-based parametric tool. Now they're all grown up and are doing a free-to-enter design competition with a pretty good winnings pool, I think. So I'm going to tell you all about it in just a tiny bit. But anyway, I think it's about time for us to take another look at this platform. And as per usual for this channel, for me to give you a tutorial on it, on how to use it. What you see on the screen, by the way, right here, is what we are going to be doing. This is Beegraphy. It's basically Grasshopper that works on any device as long as you have internet. And the main selling point, in quotation marks, is that it's truly free. The way on how they make money is by having a built-in parametric model shop where you can sell your stuff once you make it, and then they get a cut from the sale that has been made. And I think that's a pretty damn cool monetization strategy. And speaking of money, you can win some if you have some cool parametric design, if you make some cool parametric design using their tools. Of course, I'll leave a link to the competition in the description below, in the video description below. But the quick rundown is this. Anyone from anywhere can enter. It's completely free to enter. It starts mid-June and I'm uploading the video mid-June, so it probably has already started. There are 10 different categories such as fashion, furniture, lighting, I think, architecture, and so on. The prize pool is going to be $7,000, and since there are 10 categories, so $700 per category. And the most important one that you won't see on the website is Beegraphy is still really young, which means they're really small. Well, relatively small, which in turn means there's going to be a relatively small amount of participants. You get the idea. Oh, and I'm going to be one of the jury members as well. And with that, I think we can begin. Since the newest update introduced data trees, which also tends to be the nastiest thing about, well, once you're learning parametric modeling, I'll try to steer this tutorial to be about how to use data trees or data tree structures and tools associated with them, right? So there's going to be a bunch of them used here. And also, of course, this is going to be the style of the humidifier hood that I'm going to make for myself. So there's going to be a little bit of printing involved. By the end, you'll see it plopped on top of the thing that actually works. Anyway, let's jump right into it. All right, so we begin with an empty scene, and let me just quickly guide you through what you see here. Right, you have your viewport, which you can of course reposition to anywhere you want. I will hold it here, but I will make it a bit bigger so that it's kind of working with my webcam a little bit better. And then here on this side of the screen, we'll do the script. Then on the left-hand side, you see all of the tools that are available for you. Well, not quite. You only see the core and input tool sets, right? But you don't get like extrude, create surface, and blah, blah, all of those tools. Those are, you need to actually enable. They are, of course, accessible if you just double click on the viewport and just type in, polyline or something like that. There we go. It is accessible through here, but for you to be able to actually see what kind of tools there are, generally, you do need to click on this little puzzle piece icon here and choose, for example, list, right? Then this list menu pops in, and then here, if I expand it, I can see all of the different tools that are available for me that deal with lists, that deal with data trees, sequences, and so on, right? So what I like to do is I like to pop in all of the tools, except the material, because I don't, as I'm working with just pure geometry, I don't really care about the material portion of it. Okay, with that being said, I guess we can just kind of jump right into it and then just start creating, right? So for the vase, the first thing that I want to do is I want to create a circle that is going to describe the radius of the vase shape that we're going to be using, right? So I'm just going to double click and I'll just type in circle. And those of you who work with Grasshopper will know CNR stands for center, normal, radius, and that's the type of a circle that we will use. So circle CNR, right? Immediately creates a circle for us right here in the viewport. And then for the origin, I'm going to keep the origin of it as 0, 0, 0. But for the radius, I already measured the little glass thing. The radius is going to be 76 millimeters. So I'll just double click. I'll just type in 76. That gives me a number, a constant number option, which I'm going to choose. I'll just plug that in as my radius. And you can see that by default, the alignment of the circle is vertical, or rather, it's using the y-axis for the alignment. In Grasshopper, it uses z-axis, and in this case, we do want it to be flat, so I need to overwrite the normal vector. And for this, I'll just double-click, type in z, choose vector z, and just connect it to the vector input here. Congratulations, first circle done. Then for this, 1 second, let me think. Then for this circle, what we need to do is we need to create an array vertically, right? So what I want to have is a linear array. Linear array. Question is, what's the geometry that we're arraying, that we will be copying? Well, that's our circle. We just connect those like that. The direction for the array, that is going to be as well the z axis, vector z. But the amplitude for it now actually matters. As we were creating the circle initially, the amplitude for the vector, factor of 10, that the number 10 didn't matter because all we cared about was the direction. In this case, it's not just the direction, but also the step size that is described by this vector. What's the gap between the copies? So in this case, it's 10 millimeters. I want to be able to control it, so I'm going to have I can just kind of type in, let's say 20, and then we could do a range input, for instance. Connect it there. And now as I play around with the range, you can see that the circles, react to it. So that's the strength of the vector. I'm going to keep it at 20. And of course, if you expand this, you can change the minimum and maximum values of it as well. And then for the count, I also want a range input, and for it, I'll just use, or actually no, that's not something that will change too much. So it can be a constant, and we're going to do like, let's say 11 circles, just like that. For us to zoom into all of them, you can just click on this little icon right here, zoom to fit, and then it just zooms so that we can see all of those 11 circles. Okay, so now this portion right here, actually we can just select all of these, right click, and choose to create group, double click, the name, and just type in make circle. Then this, right click, create group, double click, make circle list, right? Because initially what you're getting here as the output from geometries is actually a list of circles. It's not a single circle. And the way of how you can check it is if you go to the list tab, I believe, or is it under core? Yeah, apologies. It's under core, under debug. You can see this panel option here. If you use the panel and you just connect, let's say, our little curve, the circle curve, to it, you'll see that there is, now we have our list with the length of 1, so only one item. If I expand it, there's our circle that lives in that list. Holding the Control key, if I disconnect my panel and then connect it to the linear array, you'll see that actually now we have a list of 11 elements and a longer address. And if I expand it, it's a bunch of these circles, right? From the first one until the last one. So that's our linear array, right? And a list of circles that it generates. Next up, what I want to do is I want to scale these circles according to some sort of a curve, right? So this is going to be a little bit more of a tricky way, or a tricky thing to do, but clearly we will need a scale component. Scale. The geometry that is going to be scaled is going to be our linear array, the list of circles, right? All of them are going to be scaled. And then for the factor, for now I'm just going to create 0.5 range input. And I'll just connect that to the factor just to show you how it scales, right? As I'm increasing or decreasing it, you can see that it scales down to the 000 point, the world 000 point. That's the center of scaling. So this input right now is world 000. What I want it to be actually is a list of central points of these circles, so that each of the circles scales around its own center point. To do that, it's actually pretty easy. What we'll use is a centroid component, like so. I connect my linear array geometries to the centroid input here, and what I get is this mass thing, which I believe that should be, why does it, oh, center of mass, gotcha. Okay, so if I click on it and I expand it, you can see that now I have a list of points. By the way, you don't even need a panel to check it clearly. I have a list of points and they are all at 0, 0 in X direction, but their Z value changes, right? So they are going up, and you can clearly see them highlighted here. So now if I connect my mass to my center, like so, now each of the circles scales around the center point. And at this point, this is becoming a little bit too crowded, a little bit too much. So what I'm going to do is I'm going to start hiding things. A way of how you hide things is you select all of them and you click somewhere outside of any of the nodes in the selection, right? So I just click, let's say here in this part of the window, and I click hide. And then it hides all of the nodes that have been selected. I'll do the same thing with the linear array. Select all of them, right click, hide. See? Now there is this icon here, here, and here that tells me that, okay, if you want, you can click on this to unhide it, right? Okay, so now we have our center point, we have our scaling, and now what I want to do is I want to actually scale them non-uniformly, meaning that, well, rather uniformly, but with different radii. So it's not just one number, but it needs to be 11 different numbers according to a curve. How do we do that? Well, a little bit of math. So the first thing that I want to do is I want a graph mapper, my favorite tool. Graph mapper. I right click on it, on the name of it, sorry. I'm being stupid. Oh, that's not how you do it. You click on select type and you choose Bezier. That gives you quite a bit of freedom. Bezier. This gives you this kind of a graph. And a way of how I can explain of how it works, it basically takes any value that you give it and it remaps that value to a new number, right? So in this case, if I gave it value of 0 here, right, and on the x-axis, if 0 arrives, what it's going to output is going to be 1. If 1 arrives, it's going to output 0, right? So along the x-axis, if 1 arrives, then the graph is at 0 in y direction, but at 0 it's at 1. At 0.5 it's exactly at 0.5. And I guess visually, it's going to be easier for me to show you this visually with the circles. So let's do a little bit of shenanigans. I need 11 values, right? For these. So what I'm going to say is, how do we get that number? Well, for linear array, I can just count how many circles we have with list length component. List length, connect my linear array to the list length input like so. And that just gives me 11 as my output. Great. And then what I want to do is I want to take a value between 0 and 1 and divide it up 11 times. So a way of how you can do that is with list sequence. List sequence tool. We start at 0. We end, actually not at 5, we end at 1. Make sure that, no, wait. No, that's the wrong one. Sorry. Again, list sequence. I can't write. Yeah, sorry. There's list sequence and list sequence SEC. We take the second one, the SEC one. Yeah, okay. Start and count, right? So start and we start at 0, we end at 1. And how many times do we count? We count 11 times. So what this gives us is a list of values, of course. And if I check that list, you know, it starts at 0, ends at 1, and there's 11 values in total in between them, right? Then I can connect this list to the X input of my graph mapper. And my Y output is going to be, you know, basically outputting 11 values starting from 0. So it's going to be Y value is going to be 1 and ending with 1, which Y value is going to be 0, right? And I can just simply connect that instead of the range input here. I can connect the Y output as my scale factor. And you can see how it works, right? So now with this, I can mess around. And I can, you know, make any shape I want. I think that's going to be a-okay. Sorry, I'm now just playing. Okay, with that done, we have our scaled circles that this is going to be yet another group. Make sure to group things because you really tend to, you know, after a week or so, you just forget what you've done and you go back to your script and you have no idea what it is. I'm just going to name this group change circles. No, not change circles, that's boring. Adjust circle size. There we go. Adjust circle size. Okay, so now we have our 3 little groups. That seems okay. And then we continue. Now this is going to be where it starts becoming a little bit more fun, I guess. But sorry, I'm now thinking if we should do it from the get-go or if we should do it later on. Let's do it later. You're not in my head, it doesn't matter. Just repeat after me. For these geometries that we have, I want to create a paneling system that is basically if we have one circle and we have I can't draw in paint, and we have a second circle, and then I want my panels to be basically starts here, goes up until here, goes here, here, like that, messed that one up, that, and it should be made out of 2 triangles. And you might say, oh, there's clearly, you know, it should be very easy to do. But what I want to do later, is I'll draw this in blue. What I want to do later is I want to be able to shift the list of the top panels by some amount so that the new pattern is kind of twisting, right? And that twisty motion is going to be like a variable that you will be able to control. How much is it crooked? How much is it twisted? I know, great diagram. I should sign it. Wait, there we go. 24. Take a print screen. Just eventually, this is going to hang in the museum. But hopefully that at least explains, the goal or what I'm trying to do. So initially, what we want to do is we want to divide up the bottom circle and the top circle into points, and then we want to connect those points with triangles, right? That's at least the initial idea. So let's think now. If I were to just use divide by count, right? I take my circles and I divide them, by some number. And in this case, I'll use like, let's go for 15 or so. Actually, let's use like 8. Let's use less. Later, we'll increase this. So let's say 8, right? And also, before I forget, the centroids, those are going to be in the way. So I'm going to right click and hide them. Okay, so now each of the circles has 8 points associated with them. And basically what I want to do is I want to connect, let's say this is point A, or point A1, A2, B1, B2. So what I want to do is I want to connect A1 with B1 with A2. And then B1 with A2 with B2, right? So 2 triangles is what I'm saying. With that, let's think. We will need to do some data management because already we do have a data tree on our hands. That's why I'm saying A and B, not just numbers in the list. And you can kind of see it here. It's not a single list, but rather, one branch with 8 points, second branch with 8 points, and so on. So we'll need to operate with that. Let's do this by saying, okay, if these are, actually, I do need to paint here. Right, like that. Diagram time. No, that stays black. If this is our, come on, be bigger. 1, 2, 3, and so on, right? More points. If this is our point 1, 2, 3, 4, and then we have a second circle. And for the second circle, I'm just going to do, so that it's easier for you to understand, I'm just going to do letters instead. So let's say for the second circle, like that, and that. That's going to be A. Come on, A, B, C, D, right? So what we want to do is we want to have separate lists of one for the first circle, or for each circle. We want like the initial number here, and I should probably draw this in with a different color. We want the initial number, right? Then we want +1 to it, so we get the second number, or the second point. So for 1 we get 2, for 2 we get 3, for 3 we get 4. And then what we want is we want the corresponding number or letter here, right? So one list above the list in which we're at. And then if we somehow fish all of these 3 out, then we will be able to just draw a polyline, which will become a triangle through it. Okay, so in practice, the way of how we do it is for these points, we shift list we shift the list of these points, and this is initially what it does. It just says it does that +1, right? So whatever was in the initial list set to index 1, when it's shifted is going to be 2. When it's what was 2 is going to be 3, and so on, right? The one before the last number, in this case 8, becomes 1 again, right? After shifting. So that's the plan. Okay, so we shift the list, and then let's separate them out even further into separate data branches. So, by the way, this is a really like the same thing as Grasshopper, like the way we operate with this. So what we're going to do is to separate every single point into its own little data branch. We'll use graphed tree, and we connect the points to the tree input here. So now if I show you the output, you can see it's length 1 for every single list, right? But notice how many lists there are, right? And also the addresses are not just a single number, but now it's 2 numbers, 95, 96, 97, right? So basically that's what it does. It just separates them out into separate trees, data trees, sorry. Then for shift list, I will do exactly the same thing, graphed tree, like that. And then, well, the third one is going to be tricky because the third point is going to be this, right? So we can't, for the second point, for the third point, we can't just shift the list because we're only operating within this circle right here. When we're dealing with the list, we actually need to somehow get to the next data branch. And right now, the way of how I would do it is we can flip the matrix, or flip tree in this case. Sorry, flip matrix is a Grasshopper term. And when you flip a data tree, what happens is basically all of these points that we have associated with the circles, right? They get recounted in a different way. So let me just quickly explain it with a separate diagram. That's one circle, second circle, third circle, and then we have, come on, stay green. Okay, whatever. Third circle is going to be red. We have our first point, that is ugly. First point of the first circle, second point of the first circle, third point of the first circle, fourth point of the first circle, right? Then we have our first point of the second circle, second point of the second circle, third of the second, fourth of the second, first of the third, second of the third, fourth of the third, and third of the third and fourth of the third, right? So we have these points that are associated with the circle. So we count them according to how they're placed on the circle. What flip data tree does, or flip tree does, it basically takes all of the, all of the points that are first and places them into a separate list. Then it takes all of the points that are second, it places them into the separate list. All of the points that are third places them into a separate list. All of the points that are fourth places them into a separate list, right? So it flips the logic. That's where the flip comes in, right? So flip tree, what we then can do is, since now we're dealing with lists of these points, going vertically, we can say, now I want to shift my list by 1, right? So whatever was this point here becomes this point here, right? And then I can flip the tree back. So now we're back in the, like how we started, but now what happens is that these points are actually, the points that we're dealing with are actually shifted by one list up, right? By one circle up because of this, right? So now with this flip tree done, I could just do graphed tree, separate them out, because all of these are separated, so I want to separate these as well. Separate them out. And just to make sure 100% that this works, I will also clean up the data tree information, because notice how many zeros there are in the addresses of these data trees, right? Or the branches. The zeros don't match up. So what might happen is that the polyline would fail to draw draw itself according to the points, because it wouldn't see, but because there's too many zeros, too much crap in the address. So what we can do is simplify tree. Simplify tree for this one. Simplify tree for this one. And simplify tree for this one. Easy peasy. List merge. Basically, we're just getting all of these elements into one list. Oh, notice how list merge does not give you a new input once you plug this in. That's fine. We just right click, or sorry, we just click on list 1 and we click on add port. List 2, add port, right? Because we will have like 3 lists of these. And then, moment of truth, we just draw a polyline. Okay. It's kind of doing what we need. And Boolean needs to be tick marked, by the way. So it needs to be a closed polyline. It's doing what we want it to do, except for the last bit where once it reaches the top, it goes back down again, right? And it creates the elements. Sorry, the last triangles are basically stretched out from the top of the curve, or from the top curve to the bottom curve, right? That's the issue that we're currently having. Besides that, it is triangulating as we want, so we call this a partial success. We'll need to delete those last elements there, but that's not going to be a problem. We'll do that in just a second. So for now, you'll need to, stick around with an ugly preview. That's fine. That's fine. So now what we initially have done is we created this triangle here, right? And now what we want to do next is we want to create this triangle here, right? So let's do it. So now if I go here, let's just group this up and just call it first triangle. There we go, easy. Then I'll just move this up a bit, and I guess I don't think that this should be part of the group though. Sorry. Ooh, don't do that. Control Z. No, come back. Okay, so I'll group everything except for divide by count, because we don't want to do that. Right click, create group. And I'll just name this triangle 1. Oh, oops. Delete that. There we go. So that's our little polyline tool, or polyline creation for the first triangle. Then for the second triangle, it's going to be kind of same but different. Similar to what we have been doing now, according to this logic. So we first shift the list, shift list. So our first item is going to be shifted. And preemptively, I'm just going to use graphed tree and simplify tree, both of these. I know that I'll need 3 of these, so Control C, Control V, Control V. I know that I will use merge, list merge, basically the same thing as what we're doing, what we were doing here. The value is required. What? That's weird. Let's, the moment you feel like something is off, you just refresh. Don't be afraid of refreshing your work. Yeah, now it's fine. Click plus, add port. There we go. We connect these 3. We get our little list, and that's going to be a polyline. I think it didn't like me copying things. And we will be creating a polyline. So this is identical to this. Okay, so now our first point is going to be the shifted list point, like so. Then our second point is going to be, it should be B, right? Because we go, if we do clockwise here, or sorry, counterclockwise here, here it should also be counterclockwise. So it should be the number B. So we need to do the flip tree again, flip tree for the divided points, right? We flip it, we shift list, right? We flip it again. Exactly what we were doing here. But now this is actually going to be our third point, which I can connect here, but our middle point, right? Our second point will also be shifted by 1. Like so. Shift list and connect it there. Yeah, something like that. Does this work? 1 second, I'm just thinking if this is gonna work like that. No, this should already have, yeah, it already has the polylines, right, for us. So let me actually hide all of these, and now I can see what needs to be, actually hide everything, and then enable preview of the final polylines. So these guys, bam, bam, bam. Yeah, okay, gotcha. Bam, bam, bam. So basically we are getting the polylines that we want, and then the next set is here. And what we want to do is we want to merge these polylines, the initial ones with the green ones with the purple ones, into one list, right? Into one happy family. Before we do that, of course, I right click, I create a group, and I call this triangle 2. Second triangle. There we go. Nice, nice, nice. So now for these two, we will use list merge. List merge. Connects there. Add port. Connect there. And we have all of them now in one list. And then what I want to do is I want to, basically, if I show you the list right now, it's still separated into these kind of separate panels per group, right? And then the second branch is actually these rings, right? So what I want to do is I want to have lists along these rings. So I'm going to just simply use a trim tree component. Trim tree, connect the list to the tree input. Depth of trimming is just 1. And now basically I have these lists, you know, of 16 triangles, which correspond to these rings, because I just placed all of them, you know, all of the triangles that are associated with every single circle that we had in the first place to its own list, back to its own list. So it's trim tree is basically ungraphed by 1. Right? I guess that's the easiest example. And then what I want to do is I want to get rid of the last branch, because the last branch is the one that's yucky because it goes back. So we can just take those lists. 1 second, I'm just thinking. Yeah, it needs to be, the last branch needs to be removed. So I'll use, or rather all of the branches except for the last one needs to be selected. So I'll use tree branch component. Tree branch component. Trim tree is going to be the, you know, tree that I'm going to analyze or extract from. And then what I need is tree statistics to basically understand how many branches there are, or rather to get a list of the paths for the branches, right? So the names here, path 0, path 1, path 2, you know, a list of paths. And what I want to do is, you know, to only get the first 10 branches out of 11, to eliminate the last one, I want to somehow get rid of path 10 from this list. So let's just do reverse list. I guess it's fastest to just reverse the list. Remove index, remove by index. And the index, since we reversed it, the last item becomes the first item, so the index is 0. And then I reverse list again. I think that should just work, right? We just connect that to our tree branch and put here. Yeah, you can see that only the good stuff is highlighted now. So now we just select all of this and we hide it. And I will just grab this, group it, I'll name it cleanup last branch. Cleanup last branch. There we go. So that's nice. And now basically, since all of these are already kind of good, ready to go, what I can do with them is I can use curve to surface to construct surfaces from them. You can see, it's stitches around. Great. And then for each of the surfaces, I can, what do we do with them? I want them to be dented inwards, but before we do that, actually, this is heavy. You noticed how heavy this is. So before we do that, I'll delete this. And I will show you how you can now distort this geometry so that once you build the surfaces, they are actually kind of cool and like twisty, right? So to distort it, we go back in here and we will say that, no, actually, the triangles that I have been drawing are not going to be one connects to A, but rather, let's do orange with the thickest size. One connects to, let's say, B or even to C, and then from C to D, and then from 1 to D, right? So we're distorting all of it. The offset that we're doing is much, much greater, right? And the way you can do it is by just messing around with how much you're shifting, right? So for example, in my triangle 1, if this factor is, no, this factor needs to be 1, right? Yeah, this factor does need to be shifted by 1. But then A, yeah, this letter right here, we can shift that by any amount that we want. So if I do that, and then we shift the list here, and then we flip the tree, we can introduce one more shift right here that controls, sorry, let me try that again. When we flip the tree and we shift the list and we flip the tree back, then we are basically jumping from this circle to the top circle, right? So, but then we're just selecting A, right? Because we just jump up by 1. But then we can start shifting exactly what we were doing here, in here, right? So what I'm going to do is I'm going to say, well, after we flip, we can say shift list, again, oops, not paths, shift list, like that, connect, and use this instead, use the shifted version instead. And now it's all yucky and all gross and so on. It's hard to see because we're basically not shifting the triangle 2, we're only shifting triangle 1, right? So triangle 1 becomes leaning. I think it will be best if I, for now, disconnect triangle 2 so that you visually can see what's going on. Oh, it's not happy with us. I can remove port and then it should, yeah, then it's cool with us. And now basically triangle 1 just got shifted by a factor of 1, the top the top portion of it. So let me show you with factor of 2, because I think that is going to be, come on, 2. That's going to be visually more apparent. See? So that's 1, 2, and then it jumps from this point, the top of the triangle jumps from this point by 1 by 2. So it lands here. So you end up with this kind of a form. And I can show you this form by just surface from, no, curve to surface. There we go. See? That jumps by 2. All right. So that's the idea, at least. And then what we want to happen again is if we're shifting the list here, you know, by 2, then of course for triangle 2 that also needs to happen, right? So which ones do we need to shift? Well, clearly point 2 and point 3, right? Because those are the top 2 points. And the way we can do it is, I think we do use one more shift list, or we can add to this factor of 1. So what we can do is just plus addition 2 plus, sorry, I'm just looking if I can just apply a value here. No, I can't. So I need a constant 1, like that. So here is going to be value of 3 shifted by 3, while here it's only going to be shifted by 2. Shift list. Where is it? There it is. That connects here, and here is only going to be shifted by this constant number, like so. So that should work. Oh yeah, we need to add one more port to the merge. Oh, don't complain. There we go. Connect there, and it should, yep. And then it becomes happy with us again, right? So now we are able to shift right through all of these elements and then create, you know, variants this way. Of course, for the number, constant number, I can do a shift of only 1. And then we're kind of back to solid, but, you know, reshuffled, or yeah, slightly shifted solid form, not spiky, I mean. Or if it's not being shifted at all, then it's, you know, the triangulation goes the other way. But it's fun stuff starts happening once you know, shift by 3 or 2 or whatever. Of course, if you're shifting by 3, you need much more points, or else it's just going to be, you know, quite nasty here. Okay, let's see. So now I have a lot of points that are visible. I'll just select, hide all of it, and that's what we have. Let's go back and let's finish up here. 2. So to make this 3D printable, what you want to do is you want to actually create a cap here in the top and a cap here in the bottom. And unfortunately, there's no like brep join command that Beegraphy currently has, but in my experience, just uploading it to any kind of a slicer, the slicer automatically is able to stitch things together. So as long as you provide proper surfaces in the top and the bottom, any 3D printing slicer software will be able to make this into a 3D printable shape. But we do need the top and the bottom cap, so to say. So to do so, I'm going to create, well, we kind of need to just extract the top circle and the bottom circle, right? That's all we need to do. So we go back in here for our circles, the list of our circles, and I'm just going to use list item to get the top circle, or sorry, the bottom circle, and I will use list item. I think we could just reverse the list of these circles and just get, you know, the list item 0 for this as well, which is going to be my top circle. So I have my bottom circle and I have my top circle. I will just use list merge. Bam. Add port. Bam. I'll divide them up. Divide by, or is there like rebuild curve? But that's for a curve. Doesn't matter. Let me do it the regular way. Divide by count, like that. It's important to use exactly the same count as what you use for the paneling, or else the top and the bottom cap will not match up, of course. So we divide them up, and then we just simply create a polyline through the divided points. Make sure to tick mark the Boolean for the polyline. And that is kind of it, right? Oh yeah, and curve to surface. Curve to surface, there we go. Just like that. Let me show you. There's the top surface, there's the bottom surface, right? So curve to surface generates that for us. Okay, let's group this up. I'm not going to name it, I'm just going to have it here just so that it's a little bit cleaner. And then what we do, kind of want to extend it like so, honestly, just so that we have our panels here and our surface tool or curve to surface tool right here. There we go. Then I'm just going to, I guess we just list merge. We just list our curves into here, or actually before we do that, apologies, flatten tree. We just flatten everything. So that gets flattened and copy paste. It's gonna take a little bit of time. Okay, we flatten the tree of the top and the bottom cap. We flatten the tree of the panels, and then we just merge them into one list. Add port, bam. And from here on out is just visual stuff and exporting stuff, right? Because we have our geometry done. So I'm just going to select all of this, and I'll disable the preview of it so that it's not too heavy. Right? And then we're just going to select what kind of material we're going to use, right? So for the display, I will use apply material, and by default it shows it in white color, which I like. I think that's fine. So we're just going to use that. And basically you just need to change the color for it to trigger a refresh for the material. By the way, if it gets slow, just make sure to keep refreshing your viewport. So you just F5 or refresh the browser and it's going to be fine. And then we use step exporter. I want to be able to export this as step geometry, and I want to be able to export this as STL geometry for printing purposes. And I guess that is that's where we are at right now. So, okay, let me show you a higher resolution version of this. So instead of 8, let's do 16. Let's double. And you see, after refreshing, like it's really fast at, you know, at this kind of a updating. So 16, or let's do 32. There we go. Even 32 works, right? And then for the offset, I can do 6. You know, and you get this kind of a shape. Of course, for 32, you would need more circles, right? So let's reduce this to something like 4. And then instead of 32, let's go back to those 16. 24. There we go. Something like that, right? Of course, there are other ways of how you can, not other ways, but you can do much more with this. You can create these small little triangles and, small little circles, and you can push in the geometry with the circles to accentuate the, the behavior of this, or the visuals of this. But, generally speaking, I think this is fine. And one more thing that I want to do is actually I'll drop it to 16, and I'm just going to use offset of 3, something like this. Somehow I feel like this works nicer with less elements, or maybe more circles. Perhaps we just use more circles. Didn't think about that. So instead of 11, what if we use 20? All right, and then of course the height of it needs to change. Yeah, why not? Something like this. So now to actually export this, and we will just check it in Rhino, for example. I will just go here to my the name of my file, YouTube 2024-06. Click on export. For the options, I'll just use the step file, and I'll just hit download, and it just gives me the step file. And also I'll do the same thing, but this time I'll choose STL exporter. Quality doesn't really matter. We can go for low actually, because it's only triangles here, and download that as well. Once that is done, I will just go to Rhino, open this up. Stick around until the end of the video. You'll see this 3D printed and in action. Can't wait, by the way. So that's the STL file, and we will also drag and drop in import file, join surfaces, sure, yeah, whatever. We'll import our step file. Okay, and we'll take a look at that. If I go to shade it, take a look here, seems to be a-okay. Oh, it seems like the normals for the STL, I messed up the bottom portion of it, but that's very easy to fix, and any slicing software does fix that. You just use Unify Mesh Normals tool. Unify Mesh Normals fixes that, and this is one closed mesh, as you can see, by the way, here on the top, which means perfectly 3D printable. Here, this is one block instance, so this imports as a block. If I explode it, then it's basically a bunch of separate surfaces. But then if I select all of them, type in join. Oh, cell block instance. Yeah, there we go. If I type in join, that's one closed poly surface here. Great. So that's that, right? Now you're able to work with the lists and so on, and then data trees in Beegraphy. I understand that this is maybe not the sexiest tutorial out there, but I really tried to show as many tools as I could with, different tree manipulation techniques, tree cleanup techniques, and so on. And now let's jump to the actual output. Oh, and I won't have a chance to say this, but it was a pleasure. I'll see you in the next one. Bye.